Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled the Aurora Tree. So what do we see here? Well, here we see in the foreground, we see a tree here on Earth, and getting the lineup perfect, we can see the aurora going off the branches of the tree. Now, of course, the two are completely unrelated, the tree here on the ground, and the aurora instead up high in the sky. But when you get the positioning just right, it can almost look like the aurora is coming from the branches of the tree, with the greener sections off to the right-hand side and a reddish-violet area going off from the one branch toward the left-hand side of the tree. So instead of being bare, it actually looks like the aurora are the leaves of this tree. Now, this image was taken in Iceland back in March of 2017. And was a time where there was a reasonably strong aurora visible in Iceland. Now, the aurora are caused by charged particles from our sun. So the sun emits a lot of particles in addition to just light in terms of the solar wind, which is a steady stream of particles, but it also emits bursts of particles in what are known as solar flares or coronal mass ejections. And when things like that come toward Earth, the electrons especially follow along Earth's magnetic field lines and strike Earth's atmosphere close to the magnetic poles. And that's why we always see the aurora at very far northerly or southerly locations, because that's where the magnetic field lines all come into Earth and where they intersect the atmosphere. That allows the electrons to then hit atoms in Earth's upper atmosphere, causing them to glow. Most of the glow we see here is the green color of oxygen atoms in the atmosphere. When oxygen is excited, we then get a greenish glow from it, much as we often see a red glow from hydrogen gas. Higher up in the atmosphere, we can actually get a reddish glow from the aurora too. And this is also caused by oxygen, but higher up where the density is lower and different transitions are visible. So in that case, a red transition that won't occur under denser circumstances will occur and give us a reddish glow. So it really can depend on where we're looking at what levels we're looking in the atmosphere. Under other conditions, we can also get things like blues and purple colors as well for the aurora. But primarily when you see the aurora, it's generally the prominent green color that we see here. Now, the aurora occur most often when the sun is active and we're near the peak of its cycle, which likely occurred last year. And that is when there are more sunspots on the sun and more solar flare activity, giving us more aurora. So aurora are still prominent right now, especially at northerly latitudes, and over the next few years as the sun leaves the peak of its cycle and heads toward the minimum, the auroral activity will decrease and we'll see far less of it than we do now. That doesn't mean that it stops. It will still occur, just not be as strong. There will not be as many strong storms as there are at this point. So that was our picture of the day, titled The Aurora Tree. We'll be back again tomorrow for the next picture, previewed to be Big Brained. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.